All right, so today we're going to be doing lecture 26, SOL review. So if you go to my Canvas page and you go down to week 14, you will see under Monday there is classwork 2014 Algebra 2 SOL. We're going to be doing questions 1 through 12 today. So you're going to click that. Once you do that, you'll be brought to this page. You can click on the blue link at the top, or you can click on the down arrow. That'll download it directly to your downloads folder. So when I do that, I open it up and I get this. We're going to scroll down to question number 1 and we're going to get started there. No need to do the sample questions unless you really just want to. All right, so this first one says, which expression is equivalent to 3n over n plus 3 plus 5 over n minus 4 if no denominator equals 0? So I'm going to go ahead and write that down. Three n over n plus 3 plus 5 over n minus 4. So for this one, what I'm going to do is I need to find a lowest common denominator. And to do that, I'm going to be using both of these denominators. I need the n plus 3, and I also need the n minus 4. So we're just going to multiply them together. So that's going to be my first fraction. And this is going to be my second fraction. So for the first fraction, I have the n plus 3, but I'm missing the n minus 4. So what I have to do is I need to take the top of the fraction and multiply what's missing on the bottom, and it's missing that n minus 4. For the second fraction, I have the n minus 4, but it's missing the n plus 3. So I'm going to multiply the top by n plus 3, since that's what's missing. So now I have a common denominator on both of these fractions. What I'm going to do is I'm going to simplify the top of this fraction, the top of this fraction, and then I can add the numerators together. So I'm going to start off by doing the distributive property. I'm going to multiply everything on the inside by what's on the outside. 3n times n is going to give me 3n squared. 3n times negative 4 is going to give me negative 12n. Over here, I have 5 times n. That's going to give me plus 5n. And then 5 times 3 is going to give me 15. And my common denominator is n plus 3 times n minus 4. Okay, so now I'm going to simplify the top. I've got a 3n squared that doesn't combine with anything. I have a negative 12n and a positive 5n. If I was to combine those like terms, I would get minus 7n. And then the plus 15 is going to get added onto the n. My common denominator is still going to be n plus 3 times n minus 4. And that's it. Okay, let's try the next question. This one is, which number is equivalent to negative 6 minus I? So negative 6 minus I plus 5I minus 11 plus 3I. So this one involves complex numbers. What we're going to do is we're going to put all the real numbers together, and then all the complex numbers are going to be put together in a separate set of parentheses. So what I'm going to do is I'm going to switch my color to red, and I'm going to underline all the real numbers, not the imaginary numbers. So I can underline this negative 6 right here. This negative I is imaginary, so I'm going to leave that alone for now. The 5I is also imaginary. And then this 11 is going to be a real number. So if I was to put the real numbers together, I would have negative 6 minus 11. That would give me negative 17. Okay, now let's put the imaginary parts together. I have a negative I, negative 1I, plus 5I, minus 3I. So then I would have 5I minus 4I. That would be just 1I. So I can write my answer like that, or I could write my answer like this. And that's because the 1 in front of the I is understood to be there. Okay, let's try number 3. Which of the following is the factored form of x cubed minus 216? So we've got x cubed minus 216. The first thing that I notice about this is we have cubes. And since I'm subtracting in the middle, it's going to be a difference of cubes. Since we're subtracting its difference, if we were adding, it would have been a sum of cubes. But now we've got difference of cubes. So I need to figure out what exactly is the cube root of both of these. So what is the cube root of x cubed? But also, what is the cube root of 216? So if I was to take the cube root of this x cubed, I would have x. If I was to take the cube root of 216, I would get 6. And if you don't know what the cube root of this is, you can always do it on Desmos. Okay, so to find the cube root, what you need to do is you need to go down to the keypad, open it up, and then find the cube root. It's going to be under functions, most likely. And if you go to miscellaneous, you'll see the nth root right here. We're going to click that, and we're going to make the index 3. So that way, on the inside of the radical, you can find the cube root of any number. And in this case, cube root of 216 is going to give me 6. Okay, so now I know what all the cube roots are. So how am I going to factor this? Well, I'm going to have a short factor, and I'm going to have a long factor. So doing cubes, I'm going to take the cube roots, and I'm just going to bring them down. So my first factor is going to be x minus 6. Notice that I'm keeping this sign the same. Next, what I'm going to do is I'm going to square my parts. If I square x, I'm going to get x squared. If I square 6, I'm going to get 36. But then if I multiply the two parts together, I have 6 times x, which is just 6 times x, 6x. So I put that in the middle. And then the last thing I need to do is I need to remember SOAP. SOAP, right? What do the letters stand for? Same, opposite, always positive. SOAP stands for same, opposite, always positive. So the same means that I'm going to keep the same sign right here. The next sign is going to be opposite, so I need a plus instead of a minus. And then the last sign is always positive. So I'm going to put a plus in between the 6x and the 36. And I'm done. So that is number 3. Okay, let's look at number 4. Which expression is equivalent to the square root of 75x cubed minus the square root of 27x cubed if x has to be greater than 0? So let's write that down first. Square root of 75x cubed minus square root of 27x cubed. So for this one, I have square roots, which means whatever number I have, in this case a 75, I need to break that down into perfect squares. So what are my perfect squares going to be? 1, 4, 9, 16. Those are the obvious ones, but you also have 25. These are all perfect squares, and we're going to be using these to help solve the problem. So what can I break up 75 into? I can break up 75 into 3 times 25, right? And then for the 27, what can I break that into? 9 is going to be the perfect square. So 27 is 3 times 9. We're going to be using these two numbers to help us with this. Okay, so I'm going to write 3 times 25. And I need to keep the x cubed as x cubed for now. Over here, I'm going to have 3 times 9. That'll give me 27. And I need to keep the x cubed for now. So what you'll notice here is I have perfect squares now. I'm going to underline them. I can take the square root of 25, and I can take the square root of 9. When I do that, I take them out as their square roots. So what is the square root of 25? That is going to be 5, right? What is the square root of 9? That's going to be 3. But everything else has to stay inside the square root. So I'm still going to have this 3 left under the square root, and I'm still going to have the x cubed. Those aren't going anywhere. Inside this square root, I'm still going to have this 3 and this x cubed. Okay, so now what I can do is, since I have the same radical on both sides, I can do 5 minus 3, which is 2. But notice the 3 has to stay under for now, and the x cubed has to stay under for now. Now, what I can do with this x cubed is I can break it up into x squared times x. So what is that going to look like? I can write that as x squared times x. So now I have an x squared under a square root. What can I take the x squared out as? I can take it out as a x, right? So not only will I have a 2 on the outside, but I'll also have an x. But then what needs to stay on the inside? This 3 right here and this x. They aren't perfect squares, so I need to leave them under the square root. And now you'll notice that it's fully simplified. There's nothing left that I can do. So my answer is going to be 2x times the square root of 3x. Let's try number 5. Number 5 says, assuming that no denominator equals 0, which is equivalent to the fraction r squared minus r minus 6 over the quantity r minus 2 times the quantity r minus 3. So let's write that down first. R squared minus r minus 6. And we're going to be dividing by r minus 2, r minus 3. So right now, what I could do is I could factor the top. So I want to factor this. How can I do that? Well, I would need to find two numbers that need to multiply to the -6. So drawing a chart over here, they need to multiply to -6, but they need to add up to this number that's in front of the r right here, this -1. So what two numbers will do that? To multiply to a -6, I'm probably going to need some kind of 3 and some kind of 2. But to multiply to a -6, one of these has to be negative, and it's going to be the 3. Now I'm putting the negative on the 3 because I need to add up to a -1. So I've chosen the right two numbers. It's just that the 3 has to be negative for this to work. So now what I can do is I can factor the top as r minus 3 and r plus 2 by using these numbers, the negative 3, which goes in the first set of parentheses, and the positive 2, which goes in the first set of parentheses. And the bottom of the fraction is still going to be r minus 2, r minus 3. That hasn't changed. Okay, so now that we factored the top, what factors match up on the top and the bottom? The r minus 3 is going to match up with the r minus 3 at the bottom, so I can cancel this one out. If I cancel this one out, what about the one at the top that's left, this r plus 2? It does not match up with this r minus 2, so I can't cross those out. So my answer is still going to be r plus 2 over r minus 2. Okay, let's look at 6. Which expression is equivalent to the fourth root of 16 times x to the 15th power times y to the 17th power, where x and y are greater than 0? So I've got a fourth root now. On the inside, I'm going to have 16 and x 15, y 17. Okay, so what I could do is I can break up the inside into groups of 4, because that's what my index is. So I know that 16 is going to be 4 times 4, and I know that 4 is 2 times 2. So I can break both of these up into 2 2s, which means at the very end, I'm going to have 4 2s together. So I'm going to have 2 times 2 times 2 times 2. I'm going to have 15 x's, and I'm going to have 17 y's. And my index is still 4. So now, since I have a group of 4 different 2's, I can take all this out as just 1 2. But on the inside of the radical, I'm still going to have x to the 15th power and y to the 17th power. What I can do now is I can take these exponents on the inside and I can put them at the top of fractions. So at the top of the fraction for x, I'm going to have 15, and on the bottom, I'm going to have 4, because the index is always going to go on the bottom of the fraction. For the variable y, I'm going to have 17 on top with a 4 on the bottom. So you can write them out as fractions like this. So when I look at the answer, I know that the exponents have to be fractions for this to work. So you're going to have 15 over 4 and 17 over 4 with a 2 as the outside coefficient. Let's look at 7. 7 says, which is equivalent to 6 plus square root of 7 times 5 plus square root of 7. So we've got 6 plus square root of 7 times 5 plus square root of 7. So for this one, since I have 2 terms right here and 2 terms over here, I can use the FOIL method. So what does FOIL stand for? First, outer, inner, last. So let's multiply the first 2 terms. That's going to be the 6 and the 5. If I multiply those together, I get 6 times 5, which is 30. Now I'm going to erase this one, and I'm going to underline the square root of 7 over here. So now I'm doing the outer 2 terms. 6 times square root of 7 is just going to be 6 times square root of 7. There's not a better way that I can actually write that. So I'm going to leave that like it is. Now what we're going to do is we're going to underline the inner 2 terms, the square root of 7 and the 5. If I multiply those together, I'm going to get 5 times the square root of 7. And then my last step is to multiply the last 2 terms. That's going to be square root of 7 right here and square root of 7 over here. So I'm going to get square root of 7 times square root of 7, which is just going to be 7. So going down here, I'm going to rewrite most everything, but I'm going to write the square root of 7 times square root of 7 as just a 7. So now putting the whole numbers together, I have 30 plus 7. That's going to give me 37. And then since these 2 terms in the middle both end with a square root of 7, that means that they are like terms, which means I can add those together. 6 plus 5 is going to give me 11, square root of 7. And I'm done. There's nothing left that I can do to it. Okay, let's look at number 8. I have the cube root of 162 times x to the 6th power times y to the 7th power. So I'm going to write that down first. I have a cube root of 162 times what? X to the 6th power, y to the 7th. So x to the 6th power, y to the 7th. So the first thing that I'm going to do is I'm going to simplify the number. For 162, I'm not sure if that's a perfect cube or not. It's probably not. So what I'm going to do is I'm going to break that up into different factors. I know that I can divide it by 2. When I do that, 16 divided by 2 is 8, and 2 divided by 2 is 1. So I can break this up into 2 times 81. And I know that 81 is going to be that perfect cube that I want. Why is that? It's because 81 is equal to 3 to the 4th power. So this is actually going to contain a cube. The 81, I can break that down into 3 times 27. And the 27 is going to be a perfect cube because 27 is 3 cubed. Okay, so how can I rewrite this? I'm still going to have a cube root. I know that I'm going to need 27. But I also have this 3 and this 2. And if I multiply 3 times 2, I'm going to get 6. And then the x and the y are going to stay the same for now. So now I have 27 times 6. I know that 27 is a perfect cube, so I'm going to underline that. The cube root of 27 is 3. So that means I can take the 27 out as a 3. So what's that going to look like? The 3 is going to be on the outside. And then this 6 has to remain on the inside. So inside the cube root, I'm still going to have the 6 and the variables. I haven't changed those yet, but I'm about to. So I can't take any cubes out of this whole number 6 right here. But now what I can do is I can take out all these x's in groups of 3. So how many groups of 3 can I take out of 6 x's? 2. So I can take out the x to the 6th power as x squared. And now I have to deal with the y's. So for this y right here, I know I'm going to have 7 of them. Out of those 7 y's, how many groups of 3 can I take out? 2. So I can take out y squared. But I'm still going to have 1 y left under the radical. So under the cube root, I'm going to have this 6 right here. And I'm still going to have 1 y that I wasn't able to take out. And since there are no more cubes to take out of the radical, that means that this is fully simplified, and I'm done. So on the outside, you should have a 3, 2 x's, 2 y's, and then on the inside of the cube root, you should still have a 6 and a y. All right, let's do 9. 9 says, which expression is equivalent to x to the 3/7 power times y to the 36/7? So x to the 3/7 times y to the 36/7. Yep. So for this one, notice that I have a common denominator. That common denominator is 7. So when we write this as a radical, that 7 is going to become the index. What I mean by that is we're going to have a 7th root. Now the numerator of the fraction, the top, is going to become how many variables I'm going to have on the inside. Since the top has 3 x's, I'm going to put x cubed on the inside. And since the y has a 36 on top, I'm going to put y to the 36th power on the inside. So am I done? No, not yet. So notice I don't have enough x's to take out, but I do have enough y's that I can take out. But I have to take them out in groups of 7, right? How many groups of 7 can I take out of 36? What's 36 divided by 7? Well, 7 can go into 36 how many times? Only 5 without going over. Why is that? Because 5 times 7 is 35. If I subtract 36 and 35, I have 1 left over. So that's going to become my remainder at the top. So that means I can take out 5 of the y's. So I can take out y to the 5th power. But on the inside of the 7th root, I'm still going to have that remainder 1 left on the inside. So not only am I going to have x cubed on the inside, I'm also going to have 1y. So you can write it like that, with the y having an exponent of 1 on the inside, or you could write it with no exponent. So I'm going to get rid of the 1. So you may see your answer written like that. But you should be able to take out 5 of the y's. And then notice you don't have anything left to take out. So that means you are fully simplified. Let's look at number 10 now. Number 10 says, factor the following polynomial. I have 8x squared. So 8x squared minus 15xy. Sorry, minus 18 xy. And then minus 5y squared. Okay, so for this problem, what I could do is I could see what I need to multiply to the ends and what will add up to the middle. So for this 8x squared, what would multiply to 8? I could have a 4 and a 2. So I could break that up into 4 times 2. And then over here on this side, what would multiply to negative 5? A 5 and a 1. But one of these is going to have to be negative. I just don't know which one yet. Now going to the variables, I know that I need to multiply to x squared. So both of these need to have x's at the end. So I can multiply to get 8x squared. Over here, since I have a y squared, they both need to be y's. So I'm going to have 5y and 1y. Okay, so now let's see if we can build up the factors. On the left side, I'm going to have a 4x and a 2x. So that way, when I multiply these together, doing the FOIL method, I should get back to 8x squared. And then on the other side, I'm going to have 5y and 1y. So I put those in place. Now I need to figure out where the plus and the minus go. So the way I'm going to figure out that is I need to make sure that when I add up the two middle terms, I get to negative 18 xy. So to do that, the 5y and the 2x are going to multiply to give me 10xy. But then if I multiply the 4x and the 1y, I'm going to get 4xy. But that's not good, because if I multiply those and add them up, I get 14xy. When in reality, I need this 18 right here. So I'm not going to have it that way. Instead, what I could do is I could switch up the positions of the 5y and the 1y. So I'm going to put the 5y over here and then the 1y over here. So that way, when I multiply the inside, I'll get 2xy. And then when I multiply the outside terms, I will get 20xy. 4 times 5. And then somehow I need to add up to get negative 18xy. And notice that I can only do that negative 18 when the 20 is negative. So if I put the plus right here and the minus right here, I'll have that negative 20 that I need. And I'm done. Okay, so now let's FOIL it to check. We're going to multiply the first two terms together. 4x times 2x is going to give me 8x squared. If I multiply the outer two terms, I'm going to have negative 20xy. The inside two terms are going to give me plus 2xy. And the last two terms are going to give me minus 5y squared. The middle two terms are going to add up to give me negative 18. That's what I want. And then the rest stays the same. So my answer is going to be 4x plus 1y. I don't really need the 1 out in front, so I'm going to get rid of that. And then I need 2x minus 5y in the second factor. Okay, so now we're getting to the last two questions we're going to do today, 11 and 12. So number 11 says, which statement illustrates the symmetric property? Symmetric property. Okay, so let me talk about the three properties of equality. So you're going to have reflexive, symmetric, and transitive. And all three of these are going to be different. So what the reflexive property says is x equals x. Very simple. What symmetric says is if x equals y, then we can switch the order. Y equals x. And then transitive is where we have three different variables. It's if x equals y and y equals z, then we can make a bridge between the x and the z. We can say x equals z. So those are the three properties of equality. And this one is asking for symmetric. So we need to find the statement that follows this pattern. If x equals y, then y equals x. So I'm only going to have two different variables, the x and the y, and they're both going to be equal to each other. We're just switching the order. All right, so looking at the answer choices, for A, they're not really switching the order, so that's going to be reflexive. Looking at B, for this one, they are switching the order. You have the same things on both sides. They're just switching the order of the equal sign. And then for C, they have three different variables going. So C is transitive, not symmetric. And D is something else entirely. So we're going to choose B. B is going to follow the symmetric property. So 7 square root of x plus 17i is equal to 49i. So what B is saying is if this one is true, then we can switch the order of the equal sign. We can put the 49 on the left side, and we can take the left side and put it on the right side. These two sides will still be equal. So if this, then that. That's what the symmetric property says. You're just switching the order of both sides. All right, let's look at 12. 12 says, identify each expression that is equivalent to I. So the expression has to be equivalent to I. Let's check out our answer choices. We have I to the 47th power. That's our first one. We have I to the 33rd power. I to the 21st power. And we have I to the 15th power. So we're going to be looking at all four of these and seeing if they are equivalent to I or not. Now, the one fact that you need to know is I to the 4th power is equal to 1. Because we know that I squared is going to be -1. And if we multiply -1 by -1, we get +1. So what we're going to do is we're going to break these up into groups of 4. So for the 47, I can break that up into 44 plus 3. I know that 44 is a multiple of 4. So then I'm going to have I to the 44th power times I cubed. I can break up that exponent. So then I to the 44th power is the same thing as I to the 4th power multiplied by 11. Because 4 times 11 is going to give you 44. Now, since I know that I to the 4th power is 1, that means I can replace whatever I have inside parentheses as a 1. And then 1 to the 11th power is just going to be 1. So this is going to be equal to I cubed. Since it's not equivalent to I can get rid of this one. Moving on to I to the 33rd power. How many 4s can I take out of 33? Well, I know that 33 is going to have 32 plus 1 left over. Then I can break that up into I 32 and I to the 1 power. 32 is 4 times 8. So I can have 4 to the 8th power. And then I to the 4th is going to be 1. So really I have 1 to the 8th power, which is going to give me 1. So then I have I to the 1 power, which is just I. So this one is actually going to be equivalent to I. So I'm going to put a check mark beside that one. I to the 21 power. How many groups of 4 can I take out? 5 of them, right? Because I can break this up as I20 plus 1. So now I have I to the 20th power times I to the 1 power. This is going to be I to the 4th power times 5. And that means I have 1 to the 5th power times I. And that's just going to give you I. So this one is also going to work. How about I to the 15th power? If I take them out in groups of 4, I can have 12 plus 3. So I can break that up into 2 factors, I to the 12th power and I cubed. Twelve is 4 times 3. So then I can write this as 1 cubed times I cubed, which is just 1 times I cubed. And that's just going to give me I cubed. So this one does not give me I. So I'm going to cross this one out. So then the only 2 answers that I could choose are going to be the 2 in the middle, I to the 33rd power and I to the 21st power. Okay, that is 1 through 12. On Wednesday, we're going to be doing part 2. We're going to be doing 13 through 25. So I will see you all on Wednesday.